In this video, I'm going to work through numerous examples using the concept of specific heat. Here is the first example. What is the change in temperature of 20 grams of helium if 1,000 calories are added to it? In order to do this, you need to be able to access the table that is presented in Sakai, or it's in your book as well, so that you can figure out what the specific heats are if you need them. This is asking for what is the change in temperature. So what is delta T? Given a mass of 20 grams, you're told it's helium, and if you look on that table, the specific heat of helium is 1.24 calories per gram degree Celsius, and you're told 100 calories are added to it, which in this chapter, that's energy, which is Q. So we use our formula for calculating. Q equals m delta T times C. So 1,000 calories equals 20 grams times what we want to know, delta T, times, oops, not a zero, let's try that again, 1.24 calories per gram degree Celsius. So that tells us that 1,000 equals 24.8 times delta T, or that delta T is 40.3 degrees Celsius. In the second example, you want to know how much energy is needed to increase the temperature of 20 grams of gold by 25 degrees Celsius. So how much energy? So that's asking for what is Q. You want to increase the temperature by 25 degrees Celsius. So that tells you what your temperature change is. It doesn't matter what the initial and the final is, as long as you know that it's changing by 25. Because it's gold, the specific heat of gold is 0.031 calories per gram degree Celsius, and this gives me my mass. So Q equals m delta T times C. Mass is 20 grams. Delta T is 25 degrees Celsius, and the specific heat is 0.031 calorie per gram degree C. And when you multiply that all together, you get 15.5 calories. Example 3. You have 15 grams of an unknown substance, and it's experienced a change in temperature of 10 degrees Celsius when 18.6 calories of energy are added to it. You want to know what the specific heat is, so you can't look it up in the table, and you want to use that knowledge to identify the substance. 15 grams is the mass, the change in temperature is 10 degrees Celsius, and you're adding 18.6 calories of energy, so that's Q. So Q equals m delta T times C. So 18.6 calories equals 15 grams multiplied by 10 degrees Celsius multiplied by C, or 18.6 calories equals 150 times C. And when you divide 18.6 by 150, you get 0.124 calories per gram degree Celsius. You can then look this number up in the table and determine that it is diamond. For the next example, you're adding 30 calories of energy to silver, and that leads to a temperature change of 45 degrees Celsius. You want to know what the mass is. So it's asking for, what is M? 30 calories is Q. The temperature change, delta T, is 45 degrees Celsius. And because it's silver, you can look at the table and find that that has a specific heat of 0.057 calories per gram degree Celsius. So 30 calories equals M, which we want to know, times 45 degrees Celsius times 0.057 calorie per gram degree C. So that tells us 30 equals 2.565 times the mass, or that the mass is 11.7 grams. For the final example, you're wanting to increase the temperature of 30 grams of gold by 10 degrees C and increase the temperature of 15 grams of gold by 10 degrees Celsius. And you want to know how much more energy is needed. So we're going to do a subtraction in the end. So because it's gold, that's a specific heat of 0.031 calorie per gram degree Celsius. In one case, our mass is 30. In the other case, it's 15. And delta T is the same in both cases. So for the 30 gram, it takes 30 grams, 10 degrees Celsius, 0.031. And when you multiply all that together, you get 9.3 calories. Similarly, for the 15 gram sample, that's 15 grams times 10 degrees Celsius times 0.031 calorie per gram degree C. And when you multiply that together, you get 4.65 calories. So how much more energy is needed? You need to subtract. 9.3 minus 4.65 is 4.65 calories. In this case, it worked out to be half, and that's because our mass was exactly half, 30 to 15. It wouldn't be half in general. Please keep that in mind.